So historically, in Cold Fusion, a struct, no matter how it's created, is a bag of key value pairs. And the order in which those keys are inserted becomes irrelevant, and the order in which they are iterated becomes unpredictable, though anecdotally it tends to be alphabetical. With Lucee CFML, however, there is the option to create an ordered or linked struct, which uses one of two different notations. First, we can use a bracket here instead of a brace to define our struct literal, and then you can see we provide our key value pairs the same way we would normally. And this tells Lucee to implement a linked or ordered struct implementation under the hood. And this is different because now the order in which the keys are provided to the struct or inserted into the struct become the same in which the keys are iterated later on. Or there's the option to provide the type of struct when calling the struct new function. In this case, you see we're providing the type linked, which will create the same type of struct here in which the order of the keys during iteration is the same as the order of the keys in which they were inserted. So to test this, what we can do here is create these three different types of structs, and you can see that I'm inserting the keys in reverse alphabetical order, and that's just to make the demo more interesting. We know pragmatically or anecdotally that when we dump this structure out, these keys will actually be sorted in ascending alphabetical order. However, we'll look to see what happens when we use a linked or ordered struct and provide the keys in reverse alphabetical order. And if we jump over into the browser, when we run this, what we could see again is that the normal struct, the default type, will iterate over the keys here in ascending alphabetical order. Now, it's pretty much always ascending. However, I would say that it is unpredictable in so much as you shouldn't build logic into your application that depends on the fact that these come out in a particular order. Now, however, if we look at the order or linked struct versions using either the bracket-based struct literal or the link type here in the struct new, you can see that the order of the keys is in descending alphabetical order, which demonstrates that the keys are iterated over in the same order in which they were provided to the struct. Now, this is cool, but in reality, in the vast majority of cases, the order of the struct keys to me doesn't matter. In fact, I never think of the struct as having an order. For me, it's just like I said, it's a bag of properties, and I happen to be able to reference values by key name instead of by index as I would with an array. But it did strike me that one case in which this could be interesting is the interop with an external system. For example, what if I need to call a secure endpoint in another system and I need to generate a signature that ensures that the request has not been tampered with? To do this, typically what we have to do is provide all of the data about the request. For example, the HTTP method, the endpoint that we're referring to, and then a collection of key value pairs that's typically related to the headers and the query string values. Now, if I were to pass this as a regular struct, then the order in which these inputs gets inserted into the message may be unpredictable, which means that there may be a discrepancy between the producer of the signature and the consumer, the verifier of the signature in the third-party system. However, in this case, by using an ordered struct, what it means is that we can be consistent in the way that we're providing these parameters. So if we jump down here into the generate signature function, and we see that the parameters are being passed in as that ordered struct, what we're going to do is grab all the keys here, which again will be coming out in a predictable key insertion order, and then we're going to map over those, and we're going to map that onto a set of key value pairs here, and then we're going to convert it to a list. Then we're just going to create an input message here with the HTTP method, the script name, and this collection of key value pairs that we just generated, and then I'm just going to pass this through the HMAC to create a hashed message authentication code. And what I'm going to do is I'm just going to output to the logs a signature here, so that or a pre-signature message to see what's being signed. And if we jump over here and we run this, you can see that we get the hex encoded message signature. But if we jump over into the logs, and I'm just remembering now that I didn't actually set this up to be ready to be viewed, apologies, what you can see here is that, actually here, let's clear this and I'll run this page again. What you can see here is that we are, I forgot my HTTPS. Look at this, I'm talking about methods, my signing secure endpoints, and I forgot to put HTTPS in. Let's say that one more time. There we go, HTTPS. What you can see is this is the message that here is being signed, right? If we jump back over into the code, we are outputting here the message that includes this key value set. And what you can see is that the values here, D, C, Z, and A, are in the same order in which they were provided to the signing function, D, C, Z, and A. And this way, we can ensure that the message creation for the signature process is very predictable and therefore can contain alignment between the producer and the consumer or the verifier on the other end. And anyway, to me, that's just another interesting exploration of how the ordered or linked struct could be used in Lucee CFML.